Hi, this is Ms. Kim, and today I'll be presenting the paper Is ImageNet Worth One Video? Learning Strong Image Encoders from One Unlabelled Video. Before diving into the main idea of this paper, let me briefly introduce self-supervised learning. Unlike supervised learning, which depends on labeled data, a self-supervised learning creates its own supervision signals from the data itself. For example, a model might learn by predicting mixing regions of an image or by contrastive learning, distinguish between similar and dissimilar samples from the augmented view. ImageNet contains over 1.3 million labeled images, which is expensive and time-consuming to collect. On the other hand, unlabelled video is cheap and everywhere. This paper proposed a bold idea, which is maybe a single coherent video similar to how humans perceive the world can train an image encoder as powerful as ImageNet pre-training. The authors use long eccentric 4K walking tour videos with no shortcuts. These videos provide rich object diversity, consistent temporal transitions, and varied viewpoints. The central question is, can a human-like visual stream outperform massive image datasets? The proposed method is called DORA, which is short for Multi-Object Discover and Track. In one frame, the model identifies multiple object regions using attention heads. A synchron algorithm makes sure its attention head focuses on a distinct object to get clean prototypes. The model then tracks each object across 7 frames and applies a distillation loss between the mask object crops and the full image. DORA works because it's object-centric from the start. A VIT head detects meaningful regions, and synchron ensures diversity. By tracking objects through time, the model learns both invariance and equivariance. It also compares local mask view with the full scene, helping it understand global context. And because the video is natural and continuous, it gets free augmentations like lighting and viewpoint changes. By evaluating DORA on a wide range of vision downstream tasks, we observed that it consistently achieves strong performance across the board. Not only does it perform well on semantic segmentation, object detection, and classification, but it also shows superior results in more complex tasks such as video object segmentation and object tracking. This figure shows how well the model learns to separate objects. The top row is the original video frames. The middle row shows initial attention maps, where colors often overlap between objects. After applying synchron rebalancing, the bottom row shows much cleaner result. Each object, like the car, crane, and scooter, is clearly separated by color. Even when objects change size or get occluded, the model keeps tracking them accurately. This shows that DORA learns to follow objects over time without any labels. To wrap up, we showed that a single well-chosen video can rival and sometimes beat ImageNet pre-training. The key is an object-centric pipeline that couples synchron balancing with short-range tracking, giving the encoder both spatial precision and temporal invariance. Across 6 benchmarks, we observe consistent performance lifts while using order of magnitude for fewer annotations. Going forward, scaling to longer walks, higher capacity backbones, or multimodal cues like audio could push this video-first paradigm even further. In short, self-supervised learning may not need a billion pictures, just one really good stroke. Thank you for listening.